In today's video, we're looking at measuring the speed of an air rifle pellet using a direct method and using conservation of momentum. The first thing we're going to do is to measure the mass of a pellet. Zeroing it with one of these containers on, and then I have a container with 100 pellets in it. So we know that a pellet weighs 0.54 grams. Now you do need an air rifle that is clamped down, that is mounted properly so that it can't be waved about or aimed at anything other than the experiment. There's guidance on cleats, how to adapt one. They used to be available, and it is still legal to use them in UK schools currently. So we have this one bolted down to a base. It's got feet, like you would find on kitchen cabinets, to tilt it downwards slightly so that a little railway cart, model railway cart, on the tracks will travel at constant speed, so it's compensated for gravity. Now I've set up some gates with a piece of aluminium foil across them, one there, and to begin with I've just had paper in both of them. I can see where the pellet hole is, and I can put my strip of aluminium foil across that to make sure it gets cut. Now you need an end stop. Cleats recommend a whole roll of kitchen towel with a piece of wood behind it. We've found actually that big lumps of steel work quite well. They flatten the pellet and it doesn't bounce off particularly, whereas wood, it will bounce off quite well, and therefore you need material in front of it to catch the pellet once it's been deflected or bounced by the piece of wood. So we've got some closed cell foam, whole section of it before we have a piece of wood at the back of it. We used to have an air rifle range at the school, and we found bricks and steel absorbed the pellets best. However, the Health and Safety Committee asked the Small Rifle Association what we should use, and they told us we should use wood on all the surfaces. So everything had to be covered in wood, and we had much more pellet rebound once we'd done that. I'm going to stop the video and just put the other light gate in. I said light gate and I actually meant aluminium strip. So I'm going to load the air rifle now. Everything is ready. I'm wearing safety glasses. So pellet in there. We've got a timer wired up to those aluminium strips, so it should start when the pellet cuts this one and stop when the pellet cuts the other one. So we'll fire the pellet and see if that works. And we've got 0.02. Can I get more decimal places? I think I need to change the settings on that. So we're ready for another go. And we have a time – 10.06, and that's milliseconds, I believe. Now we're going to take the gates out. And we're going to take the mass of the little model railway cart, so that's 131.7 grams, and we're going to fire a pellet into the truck. We could, if we wanted to work out its speed more accurately, put some light gates on and put an interrupter card in. Just for demonstration, we can time it over half a meter. So this will fire, the momentum of the pellet will transfer to momentum of the pellet plus the truck, and this will travel at a speed down the track, but it will travel slower, and we can work out the speed of the pellet by conservation of momentum. So here we go. So we would time that over half a meter to work out the speed of the railway truck. So working out the speed directly, 1 meter divided by the time it took, which was 0.0106 seconds. So the speed was 94.34 meters per second, which is about what I'd expect. It was almost exactly 100 meters per second when we had the air rifle new. So if we had measured the speed of the trolley, we could have worked out its momentum. The mass afterwards is 132.3 grams. And if we'd times the velocity that it travelled after the pellet hit it by that mass, and then divided that by the mass of one pellet, which we found was, container, put that on it. So that's 100 pellets is in there, so the mass is 0.54. So if we divide our momentum of the trolley, the carriage wagon, by the mass of the pellet, we should get the speed of the pellet by conservation of momentum.